Hello, learners. Welcome back to my channel Bonding with Chemistry. I'm Dr. Seema Singh, your teacher, who's going to sail you smoothly through the entire course of Class 12 NCERT Chemistry. Now, in my last video, I gave you the overview of Chapter 1, that is Solutions, which is first chapter as per the rational syllabus of CBSE. So start with me, learn with me, and prepare with me. Let's get started. Now, this was the overview that I gave you. If you want to just have a look at this video, you can refer to my link that is provided on top as well as in the description box below. In today's class, we are going to begin with solution and its type. Now, my dear learners, I'm not saying that you're going to have a direct question from this topic, solution and its type, right? But unless you understand these basic concepts, you cannot move ahead. So these topics are important to understand the further concepts from where questions are going to be put in. So you need to understand these topics without much grammar. So let's begin. Now, to understand the term solution, I'm going to take you back to your previous classes, class 9 specifically. We are going to talk about what exactly is solution. Remember, in your lower classes, you studied what is matter, anything that has mass and occupies volume. Give me a minute. I guess there's a noise from my fan. I'll just turn it off. Give me a minute. We also studied classification of matter based on chemical composition into substances, that is pure substances, and the other one which we studied was mixtures. Now, pure substances could be further divided into elements, and the other one is compounds. We'll not get into details of what are elements and compounds. Just I'll give you some examples. In your periodic table, there are 118 well-known elements. For example, sodium, carbon, copper. These are all elements. Then we have compounds. When two or more elements combine together in a definite ratio, right? They form compounds. For example, water. So you have two elements, hydrogen and oxygen. And when they combine, the ratio of 2 is to 1. Two atoms of hydrogen combined with one atom of oxygen, or if you go by their atomic masses, 2 is to 16. 1U is the atomic mass of hydrogen, 16U is the mass of oxygen. We have two hydrogens, so 2U, and this is 16. So the simplest whole number ratio is 1 is to 8. So these are compounds and elements. We are not talking about them. We're talking about mixtures. See, in general term, when I say mixture, you always feel it is mixed with something. That means it will have more than one thing. It will be combination of two or more things. The simplest example you can talk about is, let's say, in your home, you added salt into water. So what was water? Water was a compound. And it is made up of elements. Right? But when to that pure water you added salt, it is no longer pure. It is impure. It's a mixture of two things. So salt plus water is a mixture. But then there are different types of mixtures. We have homogeneous mixture and heterogeneous mixture. So mixtures can be further divided into homogeneous mixture and heterogeneous mixture. And we are interested in this mixture, homogeneous mixture, which are also known as solutions. We'll talk about what does homogeneous mean in a bit. So we have homogeneous mixtures which have another name known as solutions. To understand solution, first let us look at the definition of solution. Now, as per the definition, solutions are homogeneous mixtures. So this is a new word for us, of two or more components, right? Components, let us say parts. So what does homogeneous mean? Homogeneous means that which is uniform. They say solutions are uniform mixtures. Now, you know what is mixture. If you have two or more components that are going to be mixed together, we call that as mixture, right? That mixture should be homogeneous. It should have uniform composition and property. What does that mean? Again, let us take the same example. Let me take a beaker. If you're in the laboratory, you can take a beaker. If you're at home, you can take a transparent glass, right? Let me add water. Let's say I've added 200 ml of water. Okay. Now to this, I'm going to add, let's say, a spoon of salt. And then I'm going to stir it. You can use a spatula or a spoon. Stir it. And you will see the salt disappears, or the salt becomes soluble, or the salt dissolves in water. Now, if you have the first sip of it, now in the laboratory, I don't recommend that you drink or eat any of the chemical. Let's say, suppose you're at home and you have the first sip of the salty water. and the last sip, you will see that it tastes similar. What does that mean? It has the same composition throughout. Salt is distributed uniformly throughout. So that is very, very important. Your solution should have uniform composition throughout. Let me give you another example. For example, let's prepare lemonade. All right, it is summertime. We really relish lemonade. Again, I take a glass, transparent glass. I fill it, say, with 200 ml water. I add a pinch of salt plus half a tablespoon of sugar and squeeze in lemon. Stir it well with the help of a spoon. Let me go and stir it with a spoon. What happens? You have the first sip and the last sip. You see that the taste is similar, right? If you mixed it thoroughly and you mixed it well and you get a uniform solution, right? So it is going to have a uniform composition throughout. Then, is it made up of just one component, that is water? No. It is made up of one, two, three, four components. So two or more components, when uniformly mixed together, you get solutions, right? Now, here I would like to emphasize on a line. Mixtures have uniform composition, right? But they can have variable composition also. Now, what does that mean? Variable composition. Let me take the example of this lemonade. Now, it has a uniform composition throughout. But suppose this is a lemonade made at my home. So, this your teacher is preparing the lemonade. Now, suppose you are preparing the lemonade. Can you not alter the amount of salt, sugar, and lemon? I took a pinch of salt. You can add 2 pinches of salt. You can add a little more sugar, less of lemon, and you can increase or decrease the quantity of water and stir it thoroughly. So you are also getting a mixture. I'm also getting a mixture of lemonade. So I have a lemonade, you have a lemonade, right? Uniform composition throughout. So we have solutions, but the concentration of your solution and the concentration of my solution are different. So solutions have uniform composition, but can solutions have variable composition? Yes. I can prepare a dilute solution, you can prepare a concentrated solution, and vice versa. Right? So be very careful when I say uniform composition and variable composition. When you prepare a solution, it has to have uniform composition. But it's not necessary that the second person is also preparing the solution of the same composition. So they can have variable composition. So two solutions of similar things can have variable composition. But if you pick one, that has to have uniform composition throughout. Am I clear? All right. So let me move further. So now we know what homogeneous mixture means, right? Let us talk about the components or parts of a mixture. Now, these components or parts, you're not expecting somebody's going to ask in the exam. So, what are the components of a solution or something like that? But these terms are very important because you'll do numericals, you'll understand the further concept, and at every step, you'll come across the names of these components. All right. So, these concepts need to be understood. So, my dear children, your notes copy, you can write with me. Components of a solution. Now, to make a solution, you have to have minimum two components. We call one of the component as solute and the other as solvent. We'll refer to our standard example of NaCl, that's common salt in solid form, when you add it to water, H2O, right? Liquid. Now, generally, solvent is said to be that component which is present in large amount or greater amount. Of the two component, if one component is present in greater amount, we are going to call it as solvent, large amount or greater amount. Number two, this is the component that decides the physical state of the solution. Whether your solution is solid, liquid, or gaseous is decided by the solvent. So it helps you to decide the physical state. It decides the physical state of what? Definitely of the solution. I'm going to use the short form SOLN. In boards, it's not allowed, but I'm going to use it for your teaching method or your notes preparation. Right? So if I take example of NaCl and water, definitely your water is going to be more than NaCl. So we are going to say water is your solvent. And you also know that water is a universal solvent, right? Solute is present in lesser amount. Of the two component, the component present in lesser amount of quantity is called as solute, right? So you have salt as an example of solute. Okay, in the above example, we have salt as solute and water as the solvent. Now let us further understand this particular line. It decides the physical state of the solution. For example, NaCl in water. What is the state of water? Liquid. So this is an example of NaCl in water is an example of liquid solution. So depending on which state your solvent is, the same goes for the solution. Liquid solution. For example, if the solvent is solid, right? We'll have solid solutions. And if your solvent is a gas, we call them as gaseous solutions. All right, we'll do these types of solutions in a bit, in a while. You can just remember that depending on which state your solvent is, depending on the physical state of solvent, you have the same state of your solution. So you have solid solution, gaseous solution, and liquid solution. So if you have a numerical way says liquid solution, quickly it should come to your mind that liquid solution means solvent is liquid. Right? If they say solid solution, your solvent is solid. If it's gaseous solution, your solvent is a gas. Your solute can be solid, liquid, or gas. We're going to study different types of solutions in a little while, right? So you should be very clear that solvent is the component that will decide the state of your solution, the physical state of your solution. Clear? Now let us move on to types of solutions. Now there are two ways of classifying different types of solution. One is on the basis of, I'm going to divide them into two, on the basis of number of components. Now you know what are components, solute and solvent. How many components make up a particular solution that defines a solution. So we'll see in the form of example, number of components in a solution. And number two, which is more important, is on the basis of solvent, physical state of solvent. This one I'm going to mark important. You can have 1 mark question. All right, you can have 1 mark question from this particular topic. Number of components in a solution. What does that mean? You took an example of salt plus water. Can I say you have to have a minimum of 2 components to make a solution, right? If you have 2 components, one is solute and one solvent, you call such solutions as binary solutions, right? You know, binary means 2, so binary solutions. Now remember, my dear students, in your course, that is class 12 chemistry, you have only binary solutions, right? In your course, you have binary solution. You will have just 2 components, definitely one solute and one solvent. All your numericals will be based on binary solutions. Clear? So I'm going to mark this as important, right? I'm just going to highlight this. You need to focus only on binary solutions. Clear? Well, I'll also tell you if you have 3 components, for example, salt plus sugar, 2 solute plus water, solvent, we call such solution as ternary. You can skip this, okay? Ternary solutions. And if you have 4 components, just like the lemonade we talked about, they're called as quaternary. All right? So you have binary, ternary, quaternary solutions, and so on, right? We are only going to focus on binary solutions. You have only binary solution in your course. Clear? Now let us study about the different types of solution on the basis of physical state of solvent. Well, student, you may have, the probability is very less, but you may have a 1 mark question from here. Now you have to learn 9 types of such solutions. Now remembering these types of solution, examples of these type of solutions can be difficult. But if you draw the table with me, you are definitely going to learn with me all 9 examples by the end of the video. So let's start. So we are going to learn this in the form of a table. I'll give the heading types of solutions. I told you, you might have, probability is very less, just 1 mark question for me, types of solutions based on the solvent, on physical state of solvent. So I'm writing here solute, we'll make 4 column, solvent, what is the type of solution? So when you mix solute and solvent, you definitely get a solution. And we need to remember an example. Now this becomes a challenge, remembering an example, but if you relate those examples with everyday life, you'll be able to learn them, right? So now coming on to solvent. Now this is what decides, right? I'm going to write solid, solid, solid thrice. Why? You can have solute solid, you can have liquid, or you can have gas. Now tell me, what are these solutions called as? If the solvent is solid, solid solutions. So all 3 of them, right? All 3 of them are called as, okay, they're called as solid solutions. So mark them 3 solid solutions, right? Now coming on to the next solvent, you can have solid, now you can have liquid. liquid, liquid, liquid. All three of them will be called as liquid solutions. And the solute can vary from solid, liquid, and gas. I'll be a little slow so that you can also write down. The next form of solvent is gaseous. G, G, and G. And your solute can be either solid, liquid, or gas. Since the solvent is gas, they are called as gaseous solutions. So we have 3 solid, 3 liquid, and 3 gaseous solutions. In total, how many? 9. All right. So this part is learned. So you have solid solutions, you have liquid solutions, and you have gaseous solutions. Clear? Now, how do we pronounce the solution? We are going to say solid in solid. Just use the word in. So we're going to write here solid in solid solution. Right? How are you going to go for the next one? Liquid in solid, gas in solid, again solid in liquid, liquid in liquid, gas in liquid, and similarly. So I'm sure you can complete this side, this column, right? Now, examples. The probability of examples being asked is there from this topic, if any, right? How to remember those examples? If you start cramming 9, you'll just get confused and you will end up with an incorrect answer. Look, solid in solid. Your solute has to be solid, your solvent has to be solid, right? The best example you studied in year 9 also, your class 9 also, alloys. Just remember alloys, example of any of the alloys. Okay, alloys means, what are alloys? You have learned the definition in your lower classes. Alloys like what? Brass. Brass is an alloy. It's a mixture of two metals. What are the metals? You have copper plus zinc. Then you have bronze, copper plus tin. All right. So these are alloys, and you learned the definition. Alloys are homogeneous mixtures of a metal with a metal or a metal with a non-metal. You have to have one metal. A metal with a non-metal means iron plus carbon, your steel. Carbon is a non-metal. So if you're not able to remember any example also of alloys, just remember alloys. So alloys are the example of solid in solid solution. You're going to study a little bit about these solid solutions in chapter 4, D and F block element, as per the rationalized CBSE syllabus, right? So you have alloy, you can give any of the example, brass, bronze, German silver, stainless steel, all of them are examples of your alloys. Another good example is your 22 karat gold. This probably you will not forget, especially girls won't forget. Jewelry. Now, you do not use 24 karat gold, pure gold, to make jewelry because it is very soft. So, what you do is you take 22 parts of gold and mix it with 2 parts of either copper or silver. So, again, it's an alloy, right? So, all these examples, your jewelries, your brass, your bronze, are the examples of solid in solid solutions. Clear? Let's move further. Liquid in solid. Now, how do we remember this? Liquid. The moment you see liquid here, just remember a liquid metal. The only metal which is liquid is mercury, right? So if mercury is mixed with any of the metal, now that metal can be your copper, it can be zinc, it can be sodium, it can be silver, and so on. So there are so many metals which can be blended with mercury to give uniform composition solutions. So doesn't it sound similar to alloys? Metals mixed with another metal, right? But here the catch is one of the metal has to be mercury, right? Because it is the liquid metal. And such alloys of metals with mercury are called as special name called amalgam. You're going to study about amalgams in your organic chemistry when you do some reactions, right? There you're going to use catalyst, like let's say sodium mercury catalyst and so on. So that's called amalgam. So what amalgam? Amalgam means mixture of two things. But in chemistry, in that mixture, one of the component has to be mercury. So in solid, remember alloys. In liquid and solid, just think of a liquid metal. The only liquid metal is mercury. So we can say amalgam. And what are amalgams? Amalgams are homogeneous mixture of mercury with one of the metals. Right? Now look, mercury in silver. If you are having cavities in your teeth and you are visiting a dentist, right? He's going to use this amalgam, mercury with silver, to fill that holes of the cavity. Right? Moving on to the third one, gas in solid. Think of a solid in which there is gas trapped uniformly, okay? Do you remember any reaction? Yes, you have done this reaction also, hydrogenation, right? Addition of hydrogen. I'm writing here, hydrogenation. This is a type of reaction in which you add hydrogen in the presence of a catalyst. What are those catalysts? Platinum or palladium or nickel. So when you added hydrogen to double bond, something like this, I'll be very quick with this. When you add that hydrogen, these are the catalysts over here. Hydrogen is forming a solution with any of these metals, and that's when you use in the reaction. So the example is hydrogen with any of the metal, platinum or palladium or nickel, right? So we are done with the examples of first type of solutions, which are solid solutions. Clear? The first one, solid in solid, alloys, then amalgam, and then you have hydrogenation. That's hydrogen with platinum, palladium, and nickel. It forms a homogeneous mixture. Moving on to the next type, liquid solution. Now, this are in your course. Now, these type of solutions in course, I'm going to mark them important. First one, solid in liquid. Very easy. Solid in liquid. The most common example that I've been using, NaCl or sugar, your glucose, glucon D. You're drinking nowadays glucon D, especially when it is summer. Glucose in what? In water. Example of solid in liquid. Think of a liquid in liquid. Alcohol. Now, drinking alcohol is injurious to health, remember. So, you have ethanol. It can be mixed with water in all proportions. You can have methanol. Now, the third one is gas in liquid. You have liquid and there is gas. Now, the first example that will come to you is carbonated drinks, right? Don't drink that. They're not good for health. You have carbon dioxide in water. Fine. Instead of, we'll remember the example, oxygen in water. Now, coming on to the third category, that is gaseous solution. The first one is solid in gas. So, just remember gas means your air or nitrogen. Okay, just remember these examples from here, that gaseous side will have either air or nitrogen. Think of some solid there inside this gas. All right. Now, this solid has to form uniform composition. Okay. It has to uniformly spread throughout the gaseous solvent. Okay. So, what we're going to think of, some solid which are sublimable. What is the example? Camphor. So, camphor in air or nitrogen is an example of solid in gas, right? You can have iodine in nitrogen or air. So, these are sublimable solids. So, these are solids, they're going to form or convert into vapors phase, and you can create a homogeneous mixture. Coming on to liquid in gas. Liquid in gas. The most common liquid that comes to your mind, water. So, you can have water vapors in air. And what do we call water vapors in air? Humidity. Another example, you can think of a liquid which is highly volatile, which can form vapors quickly. Chloroform, CHCl3. You will have numericals in which chloroform is used as a solute. CHCl3, chloroform. It was also used as local anesthesia to put people to sleep or make them unconscious, right? Chloroform in nitrogen. So here we thought of a sublimable solid. Here, the first liquid that comes to our mind is water vapors, that is humidity, or think of a liquid which is quite volatile. Chloroform is one such example. So let's move on to the last example. It is very simple, gas in gas. What is present around us? What you and me are breathing. So you have air as an example. If you want, you can have a mixture of nitrogen and oxygen. Again, this is homogeneous mixture. So these are all 9 types of solution based on the physical state of the solvent. We'll quickly recall. Let's go backward. So you have gaseous solutions, solid in gas. Think of a sublimable solid. Camphor comes to your mind, the one which is used in RTs, right? Then we have liquid in gas. Liquid in gas, common liquid that comes to your mind is water. Okay, water vapors in gas, air, right? Humidity. Gas in gas, simply air, homogeneous mixture. Then you have gas in liquid, right? Liquid dissolved gases should be there. You have carbon dioxide in water, oxygen in water. Also, you have HCl. HCl is in gaseous form. We always hear about HCl as acid, right? Now, this gas, when passed over water, you have HCl aqueous, right? It is highly soluble. Oxygen is less soluble in water, whereas HCl is highly soluble in water. Even this is an example of gas in liquid type of solutions. Liquid and liquid, ethanol, methanol in water. Solid and liquid, very simple, NaCl, sugar, glucose in water. You're doing that at home, right? When you prepare mixtures. Moving on to the last category, that is solid solution. Solid in solid, remember alloys. For liquid and solid, remember amalgams. For gas and solid, just remember hydrogen gas mixed with any of the catalysts, platinum, palladium, nickel. You have been learning this in the form of a reaction hydrogenation, right? So these are the 9 types of solution based on the physical state. Now, my dear learners, I'm sure you've understood the topic. What are solutions, the components of solution, and different types of solutions? Let us check our knowledge, or let us put our knowledge to test by solving few exercise questions. There are 2 exercise questions from this topic in your NCERT, right? I'll quickly show that to you. Well, these are the 2 questions. Number 1, define the term solution. So now you know how to define the term solution. They are homogeneous mixture of 2 or more components. How many types of solutions are formed? There are 9 types depending on the physical state, right, of the solvent. Write briefly about each type with an example. You can draw that in the tabular form and you can finish up with this part of the question, right? You have any doubt? Go through the explanation part of my video. Look at the next question. Read the question well. Give an example of a solid solution. Now, when I say solid solution, I'm not reading further. First, I'll just get a clarification for this particular term. Solid solution means my solvent has to be solid, in which the solute is a gas. The solute is a gas. So we are looking forward for gas in solid. I remember hydrogen in either nickel or platinum or palladium, which is used in the reaction called as hydrogenation, that is addition of hydrogen. These are the only 2 questions from the topics that I have taught you today. Right? I'm sure at the end of the video, you are in a position to answer any question that come up from this topic. Let's say solution, its type, and the examples, right? Now with this, I come to the end of this video. In my next video, I'm going to take up the topic expressing concentration of solutions. Namely, we'll do mass percentage, volume percentage, and mass by volume percentage. Now these topics are going to have numericals, and we're going to do all numericals that are present in in-text and the exercise of NCERT. So do get your rough copies with you, pen, pencils, and since calculators are not allowed, you have to be good with your calculations. Start practicing. Alright, so see you in my next video. If you like this video, please give it a thumbs up. Do share with your peers or other learners for them to benefit. And if you have not yet hit the notification button for my channel, do hit it so that you get the latest update about my videos. So until we meet next, do take care, my dear learners, and stay bonded. Thank you.